So welcome to level 2, where we're going to look at corporate finance. And in this topic, we're going to look at what is called time value of money. Time value of money. Now, time value of money seeks to evaluate time in terms of money, whereas $1 today compared to $1 tomorrow, which would be your preference? So in this case, we are going to analyze this very, very well. So after studying this chapter or unit, we must be able to understand the concepts as follows: what time value of money means, how the relationship between present and future value are related, and also describing the types of interest rates. And also, we're going to look at computation of the present and the future values. We also want to explain to you what annuities are, both annuities due and ordinary annuities. So this is the context of what we're going to look at. Okay, so quickly, the first component simple interest. So when money has been deposited in an account, we call that a principal. Now, due to time, money can either earn value or be charged a certain interest. So the interest that we're going to look at in this course will be nominal interest, real interest, and inflation. The difference between nominal and real interest rate is what we call inflation. So if a value has been deposited in an account and it's allowed to grow, the value that we have now is called the present value. And the value that we expect tomorrow is called the future value. Now, interest can be added to this value, the principal that we have now. So interest, we're going to look at it in terms of what we call compound interest and simple interest. So the following terms are going to be essential in time value of money. TVM stands for time value of money. So we're going to look at the interest rate, the simple interest, compound interest, and how to amortize a loan, and how to compute values that are compounded more than once a year. So like I asked, would you prefer $10,000 today or 5 years later? Obviously, you'd want it today. People say chintu chintu mwene, but the reality of issues is that a 10,000 5 years from now is not equivalent to a 10,000 itself because of issues of inflation. So time is of interest, and so we're going to start with what is called simple interest. So to compute simple interest, we are going to look at the formula. Simple interest is equal to what? PTR. Where the R is the rate, our T is the time, and our P is what? The principal, the value that we start with now. Now, time is usually in years. So otherwise, if it's given in denominations other than years, for instance, monthly, this is 12 times. Annually, this is once a year. Semi-annually, this is twice a year. Quarterly, this means how many times a year? 4 times a year. Weekly, this means what? 52 times a year. And also daily, this will be 365 times in a year. Now, it is important to know the compoundings because these ones will affect your interest rate and the time period. So all interest rates will always be denoted or divided by the M, and the times will always be multiplied by the M, the number of compoundings. So if you're compounding annually, the formula will not be affected as much. If you're compounding semi-annually, we're going to divide our interest by 2. Now, to break down what I'm just explaining here, I'm going to give you a few examples. So suppose we have a principal, which is the money we started with, which is 1,000 kwacha, and the time is given as 5 years. And also we're given our interest rate as 10% per annum or annually. So we are being asked to calculate the simple interest. So remember, simple interest is given by what? PTR. Our principal is how much? 1,000. Our time is how much? 5 years. Our interest rate is how much? 10%. 10% is 10 over 100. So here and there you cancel. So we're going to get 500 kwacha. This is what we call our simple interest. Suppose our time was given, instead of 5 years, it was given as 5 months. What will be the effect of the computation? The same will be the formula PTR, except that we're only going to change on the time. 1,000 instead of 5 years, now 5 months, so 5 over 12, because 12 months make a year, then 10%. 10% will therefore give us our simple interest of 250. So if this is the interest we're going to accrue on this 1,000 that we deposited, it means our future value in this case will be the 1,000 plus the 500 to give us 1,500. This will be after 5 years. But if we're going to get after 5 months, the future value will be the 1,000 plus the 250, which will give us what? 1,250. Are we following? Okay. Of course, when you compute this properly, it's not actually 250 here. I'm not using my calculator, but you're going to have 5 over 12 times 1,000 times 0.10. It's actually 41.67. So this one will give us a future value of what? 1041.67. So this is how the procedure is. Now, when we are computing our future value using what we call compound interest, we're going to use 2 formulas here. First formula is that one of an annual compounding. So we're going to say present value is equal to 1 plus R to the power time. And the other one, we use the multiple compounding formula, which is 1 plus R over MT. Remember, M represents the number of compoundings that we are looking at. So if we have an annual compounding, the number of times of compounding is once a year. Semi-annual, twice a year. Quarterly, 4 times a year. Monthly, 12 times a year. Weekly, 52 times a year. And daily, 365 or otherwise mentioned. So we'll go through the same question here. Suppose we had a present value of 1,000. The time is 5 years. The interest is 10%. And we are told that this is compounded annually. I also taught that it is also compounded semi-annually. And also, I also taught that it is compounded what? Quarterly. So the more you compound, the higher the figure. Let's see. Annually, the future value will simply be the present value, which is 1,000. 1 plus r, 1.10 to the power 5. So you get the figure after 5 years. That is part A. Part B, since it's more than once, the formula now changes. This present value, 1 plus r over m. Remember, the interest rate is always divided by the number of compoundings and the time multiplied by the number of compoundings. So here we're going to have 1,000, 1 plus r, our r is 10%, so 0.10. Since we're looking at semi, we're going to divide the interest rate by 2, and the time, we're going to multiply the 2 times the 5 years, giving us a computation of 1,000 times 1.05 to the power 10. Remember, the more you compound, the higher the figure. So regardless of the figures that we're going to get there, you'll discover that will be increasing in value as we compound more. Can somebody try? Suppose we are compounding quarterly. What is going to happen there? Quarterly compounding. Future value is what? Present value, 1 plus r over m. Then here we have mt. So here we're going to have 1,000. But our m is quarterly, stands for the value of what? 4. So here, if we divide this by 4 and multiply the 4 to the number of years, which is 5, we're simply going to have 1,000, 1.025 to the power 20. So if you do your computations very well, you'll find that the value will be increasing as you compound more. Are there any questions so far? All right. So sometimes you'll be asked the reverse. Okay, find the time. They'll ask you how long will it take for a value to increase or to double from 1,000 to 2,000. So if it's increasing from 1,000 to 2,000, the 2,000 is obviously our future value at 10% compounded annually. So here we're looking for time. And whenever we hear how long, we're looking for what? The time. So we go to our annual formula. Future value is equal to present value, 1 plus r to the power time. So the future value being 2,000, the present value being 1,000, our interest rate is 10%, and our time we do not know. We put t. So we divide both sides by 1,000, making our t subject is going to be a little bit complex here. So here to make t subject, whenever the t is in the power, we introduce logs. Here you're going to have log 2 is equal to log 1.1 the power t. It's only the log that will cause the t to fall down. In this case, we're going to have t log 1.1. So in this case, our t is equal to log 2 over log 1.1. So in this case, we can compute that using our calculator. Okay. If you have a calculator, you could compute. In like manner, you'll be asked at what rate can a value triple, for instance, 1,000 kwacha to triple, it will be how much? 3,000. The future value will be 3,000 in 4 years, compounded annually. We'll go back to the same annual formula. Future value is what? Present value, 1 plus r at the powered time. So our future value is 3,000. Our present value is 1,000. Our interest rate, we don't know. And our time is what? 4 years. When you divide this in there, we're going to have a 3 outside here. And this is 1 plus r to the powered time, which is 4. Now here, you must always know that there's an invisible one. So to get rid of that invisible, to get rid of this 4, we find the reciprocal. Okay, or we get the 4th root. But it's easier like this. So this cancels. This would be 3 to the power 0.25. Let's go to 1 plus r. That is the only way we could work on the r. So 3 to the power 0.25, you subtract 1 to give you your interest rate. So it is basically subject of the formula. We're basically looking at subject of the formula. So this now takes us to annuities. When payments are made on a regular basis, we call them annuities. Annuities are a series of equal periodic payments that are made at the end, which is called ordinary, and beginning, which is called annuity due. So these annuities are a series of equal periodic payments. So an annuity can come in terms of rentals, as long as you're paying a regular amount, insurance premiums, as long as you're paying regular amounts, mortgage payments, all these are what? Equal periodic payments, except that if they're paid at the end of the period, we call them an ordinary annuity. If they're paid at the beginning, we call them an annuity due. So annuities have factors that you need to understand. There's what we call the present value interest factor of an annuity. It is simply given by 1 minus 1 plus r to the power negative what? Negative time over the interest rate. If you're looking at the present value, the future value interest annuity factor, of course, you'll be given tables, but it's better you memorize these formulas because it will be very easy for you to compute them over r. And each of these ones, when you multiply them times 1 plus r, what we get is called the annuity due. So if you have 1,000 kwacha, this 1,000 kwacha is put in a bank for 3 years, and the interest rate is 10%. So we're going to calculate all these annuities and annuities due as follows. So part A, find the present value present value annuity. The shortcut just write PVA. The present value annuity, you just multiply the periodic payment times the interest factor that we just calculated here. 1 minus 1 plus r to the power negative time over the interest rate. So here we have our periodic payment is 1,000. The interest rate is 10%. So here we're going to have 1.10 to the power 3 years. So here 3 over the interest, which is 10% here. So this interest factor, when you compute it, you're going to get 2.487. So this means that the present value of an annuity is actually 2,487. This is the present value of an annuity, PVA. Now to get the present value of an annuity due, what did I say? You simply multiply the answer here by what? 1 plus r, and our rate is 10%, so 1.10. So this will give us our present value annuity due. Remember, an annuity due is a periodic payment which is made at the beginning of the period. We had discussed in the previous class the types of annuities that are there. All right. So the same formulas, if you want to calculate the future value of an annuity, future value of an annuity is simply the periodic payment. And this comes in the front there, but there's no negative. So 1 plus R, the power time, minus 1 over the interest rate. So the periodic payment was 1,000. The interest rate was 10%. So 1.10. The power 3 years, minus 1 over the interest alone, 10%. So when you compute this, you're going to get our future value factor, which is 3.310. So when you calculate this, we're going to get the 310. So this is what we call our future value of an annuity. How do we know it's an annuity? They always tell you that there are periodic payments that are made that are fixed. And the future value of an annuity due will simply be multiply this one by what? 1 plus R, 1.10. This will give us our future value of an annuity. They need to take us to what is called loan amortization. To amortize the loan is simply to find a payment plan that will liquidate the loan that you have. So using the same example, suppose the loan was what? 1,000. And the loan is got a gestation period of what? 3 years at an interest rate of what? 10%. So we want to amortize this loan. Firstly, you need to know that the loan amortization formula will be payment plus the present value interest factor formula, annuity factor formula, which is given by 1 minus 1 plus R to the power negative time over the interest rate. So we want to calculate how much will the periodic payment will be making. Our loan is 1,000. Our payment we don't know, but we know that here our interest rate is 10% and the time period is 3 years. So when you compute this, we're going to find our payment. Remember the interest factor, you can use this formula way, or you can just use the table to check under 10%, under 3. So you find that our periodic payment will be 402. Now you need to understand how the table looks like. You need to understand how the annuity table looks like. So to amortize this loan, the annuity table will look like this. We have to start with the amount, beginning amount. We have to look at the payment, periodic payment we're making, the interest rate, and the amount repaid, the closing balance. Now these questions come a lot. You need to understand this procedure. So we started with a loan of 1,000. The periodic payment we've already calculated throughout is 402. So this one you just copy and paste it throughout. So our interest rate was 10%. So we calculate 10% of 1,000, it is what? 100. So we can call this column 1, column 2, column 3, column 4, column what? 5. So how do we find column 3? Column 3 is simply column 2 minus column 3 to find column 4. So 402 minus 100, we get 302. Then how do we find column 5? It is simply column 1 minus column 4. The beginning amount and the amount repaid. So here we're going to get 698. Now 698 becomes what? Column 5 brought down. Comes the opening balance here. 698. Column 3, we said it is what? Column 1 times the interest rate is 10%. So 10% of 698, it is 69.8. 69.8. So column 4, what do? We subtract 402 minus 69.8. So this is 332.2. And how do we get this one? We subtract it from 698. So here we're going to have 365.8. So this will be the opening balance, 365.8. So here, 10% of this one will be 36.58. When you subtract this from 402, we're going to get 365.8 approximately. So when you subtract this minus that, we get a 0. It means you have amortized your loan. So this is basically how loan amortization is done. You want to find a repayment plan that will liquidate your loan completely. Repayment plan that will liquidate your loan completely. All right. So any questions so far? So we looked at time value of money and the interest, simple interest. We looked at time value of money and the compound interest. We looked at the annuities and amortize the loan. Okay. So
hey, Colin. Colin.
yes, I can get
Hi,
you.
Colin.
I can hear you.
Oh, okay. Oh, okay. Just here on the amortization here. You are
Yes.
saying you're trying to pass the repayment plan that will liquidate the loan completely. So in this case, you're saying this paying 365.8 a month.
No, the monthly amount will be 402. This is constant repayment that we'll be making. It's a regular payment.
Okay.
On top of that, we have interest, and this is just the amount you paid from the total, then the opening closing balance. You start there. This will be fixed, the interest that is payable. So these are the two key things. It will not always be zero or dash, but it will just show that a figure is small or paid per adventure completely. So here I've actually rounded off. You actually get negative 0.7. Yeah.
Okay. So in short, this person will be paying that 402 plus that interest there,
Yes,
like
yes,
in
yes,
year one.
exactly, yes. Paying this one
Oh,
plus the interest in year one. This one plus that in year two. This one. Yes, exactly. That is exactly, yeah. Any other
okay, thank
questions?
you.
Any other questions? So I'll send you questions on time value of money. I've compiled all questions that were done on time value of money. And yeah, you do well to have a time to look at them. So these questions are topical. I sent them the revision kit to every one of you. So time value of money questions come like this. You want to borrow with quarterly repayments. So I'll send these questions that are that you can try them on your own, pick on any of them, then submit them. All right, thank you so much for your time and have a good day.